Okay, so hi everyone. This is the second part of our ionic nomenclature video. And today we're going to focus on transition metals, which are a little bit different because they can vary their number of valence electrons. And we're going to use Roman numerals to help us out with the naming. Okay, so first, how many valence electrons do transition metals have? Well, it varies. As a result, the charge of the transition metal ion can also vary, although they will always be positively charged. We know metals are always positively charged, and they're going to give away their extra electrons. So because of this fact, we cannot determine the charge of the transition metals simply based upon their location on the periodic table. Instead, we're going to use Roman numerals as a way to represent their charge and use the rest of the equation or the name to help us out. Okay, so first, a little bit of a review about Roman numerals, because it might have been a while since you first thought about them. So Roman numerals are what we see on that right-hand side of that table. So the I, IV, V, and VI. Those are the ones you're really going to have to worry about for chemistry. Obviously, there's a lot more Roman numerals than that, but we're just kind of focused on these 6. Okay, so there are some exceptions to the idea that we're going to use Roman numerals with transition metals. First of all, some transition metals don't need Roman numerals because they always have the same number of valence electrons and the same charge. So the 2 that we're going to have in this case are silver, which is always going to be +1, and zinc, which is always +2. Because it's always the same thing, we don't need Roman numerals. However, I won't take off if you put them on because they are transition metals. And then there are a few other metals that are kind of funny in that they need Roman numerals because just like the transition metals, they can vary their number of valence electrons. So those examples include tin and lead, which can either be +2 or +4, and then antimony, which can either be +3 or +4. Okay, so let's go over how to write ionic compounds with transition metals. Well, it's pretty similar to what we were doing yesterday. We remember we write the cation first, the anion second with that line box template. We're then going to crisscross the superscript numbers and fill in the boxes. And remember, we get the charge for the transition metal from the Roman numerals that are used. If necessary, reduce the subscript numbers, place the cation on the first line, anion on the second line. And if there's any polyatomic ions and we have more than one, we add those parentheses. And then we rewrite our answer to make it look nice. So let's go through some examples of this. Okay, hi everyone. I want to work through some examples of these for you. So the first one is copper 2 chloride. And remember, this Roman numeral, the II, means 2. So when I go ahead and do this, I'm going to have my line box. Remember, that's the great template for when you're getting started with this. Eventually, once you get more comfortable writing chemical formulas, you won't need to do that anymore. But it's a good place to start, line box. So remember, my cation or my metal goes on the first spot. So that's going to be Cu, and it has a charge of +2. Remember, metals are always positive, and we know the number because of the Roman numeral. Okay, and that's specific for transition metals. Again, remember, for the other metals, we figure out their charge based upon the periodic table position. Okay, and then we have chloride, which stands for chlorine. Okay, and that's going to be -1 because chlorine is a halogen. Okay, so now I'm going to go ahead and I'm going to flip-flop the charges. So just the numbers, not the signs, okay? So the 2 is going to go there, and the 1's going to come over here. So we're going to fill that in, 1 and 2. Now, if I look at these, I can't reduce them anymore because they're already as low as they can go. For 1s, I can go ahead. I don't need to write those, so I'm just going to cross it out. So my final answer for this one is CuCl2. Okay, let's do the next one. So iron 3 nitrate. So remember, we're going to do the line box. Okay, so our iron, remember that is Fe, and it's going to be positive because it's the metal. Its charge is 3 in this case. And then we have nitrate. So nitrate is NO3, and nitrates are -1. Okay, so again, take the numbers, not the charges, and we're going to flip-flop them. Okay, so the 3 and the 1 are going to trade places. But remember, the subscript from the polyatomic ion we do not touch. Okay, so we get a 1 and we get a 3. Now, if I look at this, my polyatomic ion, that's my nitrate, I have a number in the box that is greater than 1. I have 3 of them, in fact. So I'm going to need to add parentheses around that ion. Okay, so if I go ahead and rewrite this so it looks nice and neat, I have Fe. I don't need to write the subscript of 1. And then I'm going to have my parentheses. NO3, remember that 3 with the oxygen keeps along. We don't move that anywhere. And then the 3 for the subscript. Okay, so let's try the final example. Zinc sulfate. Remember, zinc always is +2, so that makes our life a little bit easier. So we have, got a little too excited, line box. Okay, so we have zinc, which is +2, and then we have sulfate, which is SO4, -2. Okay, so I'm going to flip-flop my numbers, not the signs. So I get a 2 and a 2. And if I look at this, I can reduce them. 2 and 2 can get reduced to 1 and 1. And when I do that, I don't need to write the ones. So my final answer for this one is ZnSO4. Okay, hope this helps. Bye. Okay, so the other thing we need to be able to do is to name ionic compounds involving transition metals. So this is, again, pretty similar to yesterday. The main thing is if the cation is a transition metal or one of those other tin, lead, or antimony elements, we need to add Roman numerals to indicate its charge. And we're going to figure out the charge of the transition metal based upon the anion. Okay, so the step 2, this remains exactly the same. The anion is monatomic. We have the "ide" ending. If it's polyatomic, we just use the polyatomic ion name. So let's try some examples of this. Okay, so hi everyone. Now we're going to go ahead and name the following compounds. So if I look at this, I have Fe and Cl. Well, Fe is iron, which I know is a transition metal, so I'm going to need some Roman numeral. I'm not sure what yet, but I'm going to figure that out. And then Cl stands for chlorine. So remember, when it ends in -E, when it's a monatomic ion, we're going to change the ione to the ide form. So it's going to be iron something chloride. Okay, so now let's figure out the charge of the iron. Well, the important thing to remember here is that we have to have charge balance, meaning for every negative charge we have to have the same amount of positive charge. So we're going to do a little bit of a simple calculation. So for my chlorine, okay, I know that chlorine has a -1 charge. And in this case, I know that I have 2 of them. So if I go ahead and multiply that together, I know that I have -2. So for my iron, I know I have to have +2. And in this case, I only have 1 of them. So because the iron, there's only 1 of them, it has to be +2. I know that its charge must be +2. Okay, so iron 2 chloride. Okay, so let's try the next one. Okay, so the next one, PbO2. Well, Pb, I know, stands for lead. And again, that's a not really transition metal, but it still kind of acts a little funny like one. And then we have O, which I know stands for oxygen, so that's going to be oxide. So lead something oxide. So let's figure out the charge for that. So I have O2. Okay, well, I know that for oxygen, I have a -2 charge, and I have 2 of them. So I know that means that I have -4. Okay, so for my lead, I think about my lead. Okay, I know I have to have charge balance, so I know I have to have +4. And since I only have 1 lead, well, must be +4. So that is the Roman numeral IV. Okay. My next example, CuO. Okay, well, Cu stands for copper. Again, Don't know what its charge is, so I'm going to leave a spot for it, and I'm going to come back to it. And now I have oxide. Okay, well, if I think about this example, for oxygen, I know that it has a -2 charge, and I have one of them, so I have -2, which means for my copper, I must have +2 to cancel out, and again, I just have one of those, so my charge must be +2. Okay, so for all of these examples, I just had one of the metal, but if I had something a little bit different, okay, so if I had Pb2O3, okay, well, again, I know I'm going to have lead, and that's going to be something oxide, okay, so for my oxygen side, I have a -2 charge, and I know that I have 3 of them, so I have a -6, which means for my lead, this time I have 2 leads, I have to have a +6 to cancel it out. So to figure out the charge of each individual lead, I'm going to divide that +6 by 2, and that's going to give me +3. So this is lead 3 oxide. So I hope that helps. Please let me know if you have any questions. Bye.